Hello dear students, let us solve some numerical problems from capacitors. At first let us review the related formulas. First formula, charge on a capacitor is given by the relation Q is equal to C into V, where C is capacitance of capacitor and V is the potential difference. So C will be equal to Q by V. Its unit is farad when charge is in coulomb and V is in volts. When two separately charged capacitors are connected in parallel, then the loss of energy due to sharing of charge is given by delta U is equal to half C1 C2 upon C1 plus C2 into V1 minus V2 whole square. Next, capacitance of spherical capacitor is given by C is equal to 4 pi epsilon naught into R, where R is the radius of sphere. Next, capacitance of parallel plate capacitor with air is given by C is equal to A epsilon naught upon D, where A is area of each of parallel plates and D is separation between them. Next, capacitance of parallel plate capacitor with dielectric is given by C is equal to A into epsilon upon D, where epsilon is equal to epsilon naught times epsilon R. So C is equal to A epsilon naught epsilon R upon D, where epsilon R is the dielectric constant of dielectric. In parallel combination, resultant of parallel capacitors is C1 plus C2 plus dot dot plus Cn, whereas in series combination of resistors, resultant capacitance C in series is given by this relation 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus dot dot plus dot dot 1 upon Cn. Dielectric constant or relative permittivity of dielectric medium is given by relation epsilon R is equal to epsilon upon epsilon naught, where epsilon is the permittivity of dielectric and epsilon naught is the permittivity of air or vacuum. Next, energy stored is equal to half Q into V is equal to half CV square is equal to half Q square upon C. Energy density is equal to half epsilon naught into E square, where E is electric field intensity, which is V by D. E is equal to V by D is electric field intensity. Now question number 1. Find the capacitance of earth if its radius is 6.4 into 10 to power 6 meter. Solution to question first. Assuming earth as a sphere of radius 6.4 into 10 to power 6, capacitance C will be equal to 4 pi epsilon naught into R. 4 pi epsilon naught will be equal to 1 upon 9 into 10 to power 9 and 6 is 4 pi epsilon 0 is 1 upon 9 into 10 to power 9 and R is 6.4 into 10 to power 6. So we get C as 7.1 into 10 to minus 4 farad. Question number 2. Two spheres of radii 2 cm and 7 cm are connected in parallel. Find the resultant capacitance. Now, solution to question 2. If C1 and C2 be the capacitances of these two spheres, then In parallel, resultant capacitor is given by Cp is equal to C1 plus C2. C1 is 4 pi epsilon naught R1. C2 is 4 pi epsilon naught R2. 4 pi epsilon naught taken common into R1 plus R2. Its value is 1 upon 9 into 10 to power 9 into R1 plus R2 is 0.02 plus 0.07 meter in SI unit. So, on simplification we get C P as 1 into 10 to minus 11 farad, which may be written as 10 into 10 to minus 12 farad, and we know 10 to minus 12 is known as pico, so this is 10 picofarad. Find the capacitance of a parallel plate capacitor with area of each plate 100 cm square and plate separation 1 mm with the mica sheet of dielectric constant 6 between two plates. So, solution to question 3. For parallel plate capacitor, with the dielectric C is equal to A epsilon naught epsilon R into upon D. Here A is given to be 100 cm square, 100 cm square, which is 100 into 10 to minus 4 meter square. Separation D is 1 millimeter, which is 10 to minus 3 meter. Dielectric constant is 6. Therefore, C will be equal to 100 into 10 to minus 4. Epsilon naught is 8.85 into 10 to minus 12, and epsilon R is 6 upon D is 10 to minus 3, 5.31 into 10 to minus 10 farad. Question number 4 is, a capacitor is connected to 40 volt battery. Find the capacitance and energy stored if it carries 8 microcoulomb charge. So, solution to question 4, given B is equal to 40 volts, charge Q is equal to 8 microfarad, means 8 into 10 to minus 6 farad. First we have to find C. C will be Q by V. Q is 8 into 10 to minus 6 and V is 40. So we get 0.2 into 10 to minus 6 farad, which is 0.2 microfarad. And energy stored is equal to u is equal to half c into v square, which is 1 by 2. C is 0.2 into 10 to minus 6 into v is 40 square, which gives energy stored as 1.6 into 10 to minus 4 joules. Next, question number 5. An air capacitor is given charge 20 microcoulomb, raising its potential difference to 200 volts. If a dielectric is inserted in it, the potential falls to 50 volts. What is the dielectric constant of the dielectric? Now, solution to question 5. Here, charge Q is equal to 20 microcoulomb, which is 20 into 10 to minus 6 coulomb. For air capacitor, for parallel plate air capacitor, Q will be equal to C into B. This is A epsilon naught upon D into B, equation 1. And for parallel plate, capacitor with dielectric, Q will be same from the law of conservation of charge. This will be C dash into B dash. So C dash becomes A epsilon naught epsilon R upon D into B dash. This is equation 2. Equating 1 and 2, we get A epsilon naught upon D into B is equal to A epsilon naught epsilon R upon D into B dash. A epsilon naught upon D cancels out, so we get epsilon R as B upon B dash. B is 200 and B dash is 50. So we get dielectric constant as 4. Now question number 6. 8 identical water drops are equally charged with similar charges. They combine to form a big drop. Compare the capacity and potentials of big to small drops. Now solution to question 6. As the total volume of n identical drops is equal to the total volume of combined big drop, therefore volume will be equal to n into 4 by 3 pi r cube for n identical small drops, which is equal to 4 by 3 pi r cube. Volume of combined big drop, 4 by 3 cancels out, and we get capital R as n to power 1 by 3 into small r. In this case, capital N is 8, therefore R will be equal to 8 to power 1 by 3 into R, which gives 2 R. Now, capacity of big drop to capacity of big drop to capacity of small drop will be equal to 4 pi epsilon naught into R upon 4 pi epsilon naught into small r. 4 pi epsilon naught cancels out. This is R upon small r, and R is 2R. 2 small r upon R, which gives 2 is to 1. And potential V dash or V of big drop upon V of small drop will be equal to, as voltage is Q upon C big upon small drop. One small drop carries charge Q. So Q upon C small, which can be written as capital Q is total charge on 8 drops, that is 8Q upon C big into C small upon Q. Q cancels and we get 8 into C small upon C big is C small upon C big will be equal to 1 by 2. That is ratio will be 4:1. This is the ratio of the potential of big drop to small drop, and this is the ratio of capacitance of big drop to small drop. Question number 7 is 2 microfarad capacitor is charged with 50 volt battery and 3 microfarad capacitor is charged with 100 volt battery. Now disconnected from their batteries, both capacitors are connected in parallel. Find the energy loss due to parallel combination. Solution to question 9. We know energy loss due to sharing of charges by parallel combination is given by delta U is equal to 1 by 2 C1 C2 upon C1 plus C2 into V1 minus V2 whole square. Now putting the values, we get 1 by 2, C1 is 2, 10 to minus 6, C2 is 3 into 10 to minus 6, C1 plus C2 will be 5 into 10 to minus 6 into V1 is 50, V2 is 100 square here, C1, C2, V1, V2, and on simplification we get 1.5 into 10 to minus 3 joules. Next question number 8. A thunder cloud has area 50 kilometer square and is at a height of 1 kilometer from earth. Find the energy stored on it if it has a potential of 100 kilovolt. Now solution to question 8. given A is 50 kilometer square, which is area of thundercloud. 50 into 10 to power 3 square means 10 to power 6 meter square. This is area of thundercloud. D is the distance of thundercloud from earth, 1 kilometer, which is 1000 meter. Potential difference between thundercloud and earth is 100 kilovolt, means 100 into 10 to power 3 volt. We have to find energy stored. Therefore, energy stored will be equal to half C into V square, where C is the capacitance of parallel plate capacitor constructed by the thundercloud and equal area of earth below it, that is 1 by 2 A epsilon naught upon D into V square. 1 by 2 is 50 into 10 to power 6. Epsilon naught is 8.85 into 10 to minus 12. 10 to minus 12. D is 1000 meter and B is 100 kilo, means 10 to power 3 square. On simplification, we get in 2212.5 joules. Next question number 9. In the given diagram, find resultant capacitance between points A and B. Solution. Here capacitors C2, C3 and C4 are in series. Therefore, if their resultant capacitance is denoted by Cs, then 1 by C series will be equal to 1 upon C2 plus 1 upon C3 plus 1 upon C4, that is 1 by 24 plus 1 by 12 plus 1 by 8. 1 by Cs will be equal to LCM is 24. 1 plus 2 plus 3 means 6 upon 24 means 1 by 4. Therefore, Cs will be equal to 4 microfarad, means resultant of these three capacitors is 4 microfarad. Now this resultant 4 microfarad is in parallel with the C5. Suppose this is point small a and this is point small b. So resultant of these two parallel resistances will be C between A and B will be equal to C series plus C5, which is 4 microfarad plus 4 microfarad means 8 microfarad. Now this total capacitance is equivalent to 8 microfarad. Now this C1, this CAB and C6 are again in series. Therefore, 1 upon C between A and B will be equal to 1 upon C1 plus 1 upon CAB plus 1 upon C6, that is 1 upon 5 plus 1 upon 8 plus 1 upon 6, which gives LCM as 120. 24 plus 15 plus 20, which is 59 upon 120 upon 59, which is nearly 2 microfarad. So the resultant capacitance between points A and B will be 2 microfarad. Next question number 10. A capacitor of capacitance 2 microfarad is charged with a battery of 100 volts. Now disconnected from battery, it is connected in parallel with the other capacitor of capacitance 3 microfarad, which is initially uncharged. Find the common PD and charge on each capacitor in parallel. Solution. Initial charge on C1 taken from battery is Q1, which is C1 into B1. C1 is 2 microfarad, means 10 to minus 6, into B1 is 100. This is 200 into 10 to minus 6 coulomb. Now in parallel combination, in parallel, C parallel will be C1 plus C2. C1 is 2 microfarad, C2 is 3 microfarad, means 5 microfarad, 5 into 10 to minus 6 farad. Therefore, common PD in parallel will be equal to, suppose that is B dash total charge upon resultant C. So Q1 plus Q2 upon C parallel. Q1 is 200 into 10 to minus 6. Q2 is 0 because second capacitor was initially uncharged. Upon Cp is 5 into 10 to minus 6. It gives 40 volts. This is common PD. Therefore, charge on C1 will be Q1 dash C1 into B dash. C1 is 2 into 10 to minus 6 into B dash is 40, that is 80 into 10 to minus 6 coulomb, and charge on C2 will be, that is Q2 dash C2 into B dash. C2 is 3 into 10 to minus 6 into B dash is 40, that is 120 into 10 to minus 6 coulomb.